So friends, today we will see the crashing of the network. So basically the crashing means to reduce the duration of the project. If it is an emergency that the project should be completed before the estimated date. So in that case, due to the need of that particular project that should be completed before that due date, then crashing is nothing but the reducing the time duration of the project by employing more resources, that we can utilize more resources to complete that project before the scheduled date. Okay, now we will see the problem of the crashing. Here the problem is given that the activities are given, the normal duration of the project in week and the normal cost required for doing that project, then the crash timing and crash cost is given. Okay, so from table you can see that if the activity 1 2 is there, normally it requires 3 days, but by doing the crashing you can reduce that activity from 3 to 2 weeks. From 3 weeks to 2 weeks you can reduce, and normally for the 3 days the cost will be 300. If but you can, if you want to reduce that activity, the crashing cost for the 2 days will be 400 for 2 days. Means here for the 3 days you require normal cost 300. If you reduce that project in 2 weeks, you will require rupees 400. So crashing is nothing but the, employing more resources in terms of means or machinery. Okay, so here the activities are given and the normal duration for that activity are also given, and the normal cost and the crashing time. Crashing time means up to how much you can reduce that normal activity, that is given here. Okay, so here the indirect cost is given that rupees 50 per week. Indirect cost is nothing but it it is totally dependent upon, it is a variable cost and it is dependent upon the duration of the project. So indirect cost includes that it may be the electricity, it may be the some bills, it may be the official cost that is directly related with the duration of the project. So here the question is, point number A, draw the network diagram, identify the critical path. Then the question B is, what is the normal project duration and associated? If we do not crash the network, what will be the normal duration of the project and what will be the normal cost? Then C, crash the relevant activities systematically and determine the optimal project completion time and cost. So if we crash the whole activities, whole project, what will be the duration of the project and what will be the cost? What will be the total cost of the project? And the question is, what will be the optimal duration of the project and optimal cost? Optimal cost means up to a certain level you can crash the network, and beyond that limit it is costly affairs for the owner to crash the network, because it will increase the project cost. Even though time is reduces, the cost of the project will increase. So that is not favorable condition for any project leader. Okay, so let us see how the problem is solved. You have to first calculate the cost slope. Cost slope is nothing but the crashing cost per week or per day, that is the cost slope. Here the formula for the cost slope is given, that is crash cost minus normal cost upon normal time minus crash time. Hence for each activity the cost slope is calculated. If we calculate, if you consider the activity 1 2, the cost slope is 100. Means if you crash activity 1 2 by 1 week, it will cost rupees 100 per week. Similarly, take activity 2 5. If we crash activity 2 5 for 1 week, it will cost us rupees 45 per week. So that is the indication, that is the cost slope, that is very helpful for crashing the network. So the network diagram for the above project is drawn here, and the time duration for the project is also calculated by using the forward and backward pass method. So total duration for the above project is 32 weeks, and here the critical path is indicated by the double line. Okay. So the normal duration of the project for is 32 weeks, and the associated normal cost, that is direct cost plus indirect cost. So direct cost is nothing but the sum of these normal cost, that is column number 3, that sum of this normal cost for all the activities, it will be around 4220, that is the direct cost, plus 50 multiplied by 32, that is 50 is nothing but the indirect cost per week, and the total duration is the 32 weeks. So total is 5820, that is the normal cost required for the project for the duration 32 weeks. Okay. Then let us start with the crashing of that network. So in the our problem, we can crash the total network, that is from 1 to 8 up to that that is given, that for activity 1 2 2 5 5 6 6 7 and 8. Okay. So from this table here we can calculate up to what duration we can reduce that network. So here from the 1 2, then 2 5, then 5 6, then 6 8 7 8, that the crashing time is calculated here, and that is about 25, means up to 25 weeks we can reduce or we can crash the network. So this is calculated step by step. So here we will see crashing activity 5 6 first by 2 weeks. Here we can see that in the left hand side table, that activity 2 5 and 5 6, that is having cost load 45. We will crash that activity which is having minimum crashing cost per week, that is 45, having that should be crashed first. Hence we have two options, 2 5 and 5 6. We can crash activity 5 6. Okay. So up to how much time we can crash that activity 5 6? We can crash activity 5 6 by 2 weeks, that is from 6 to 2, 6 to 4. Hence it is indicated by a red cross. Okay, here. And by crashing that activity by 2 weeks, the time duration, again we have drawn the network and the time duration is calculated, it is 30 weeks. Okay. So the critical path is shown, and now the new total cost is calculated, that is direct cost is same, that is 4220. Indirect cost, that duration is changed, that is 30 multiplied by 50. Then crashing cost is added here because we are going to use more resources. If you we are crashing it by 2 weeks, hence 2 multiplied by 45, that is 90. Hence the total new cost is 5810. Previously the normal cost is 5820 and here cost is 5810. Hence by crashing 2 weeks, means by reducing the network duration by 2 weeks, we are reducing the time as well as we are getting the lower cost, that is 5810. Now we will see, again we are crashing. Now here we can see that for as we have crashed activity 5 6, now we will crash the activity 2 5. But if we crash activity 2 5 by in our table, we can reduce that activity from 8 to 6 weeks, but this is not possible because if we crash activity 2 5 by 2 weeks, our critical path will change from 1 2 3 5 6 7 8, and this is not permitted in any network. Hence we can crash activity 2 5 by only 1 week, and at the same time another critical path is developed, because the duration you see that from 9 to 8 we have reduced that time, and again that here the two critical paths is formed, that is 1 2 5 6 7 8, 1 2 3 5 6 7 8, and the duration of the project is 29 weeks. Okay, so and the new total cost is, as you have seen that the direct cost is always same, that is 4220, indirect cost, that is duration reduced, that is 29, and that is 1450, and the crashing cost. The crashing cost, you have to consider the cost of the previous activity, that is 2 multiplied by 45, because we have expended that, we have spent that resources. Again, now we are taking for 1 day, 1 week, 1 multiplied by 45, that is rupees 135. Now the total is 5805. Thus we have reduced the duration from 32 to 29, and the cost is reduced also, that is 5805. Okay, now again step number 3. Now we can crash activity 6 7 by 1 week, because up to 1 week, from 4 to 3 weeks we can reduce the duration of the that activity 6 7. So we are crashing the activity 6 7 by 1 week, and the slope for the 6 7 is 70 rupees per week, and the duration, we are drawing the network again, and all the crashing activities are indicated by a red cross. Okay, so here the duration of that project is 28. Okay, and here the 3 or 4 paths, new another path, critical paths are developed if we crash activity 6. This is permissible. Okay, now see the costing of that project, that the new total cost is, that is 4220 plus 28 multiplied by 50, then 2 multiplied by 45, that previous crashing activity should be considered, that we then now we are crashing it by 1 week, and it is multiplied by 70. Now the project cost is 5825, that the project cost is increased and the duration is reduced. Okay, similarly now after that 6 7, 6 7 slope was 670. Now see the activity 1 2, because gradually as the we are crashing by using that cost slope table. Now where we will crash activity 1 2 by 1 weeks. Here it is indicated by cross, and the new duration of the project is 27. Okay, now the cost is increased, as you have seen from the table that the project cost is increased, that is 5875. Okay, the cost is going to be increased. Now see that now we have to crash the activity 25 and 35 by 1 week. Now we have 1 week remaining in the activity 25. Okay, so we can crash activity 25 and 35 at the same time, okay, because if we crash activity 25 only, then the our original critical path will change. That's why if you do not want to change that critical path, you should crash the activity, that is 25 and 35 at the same time by 1 week. Okay, and here we see, if by crashing this activity, two activities, that another all paths are critical paths. Okay, now the duration of the project here is 26 by crashing activity 25 and 35. Now see the total duration of the project, total new cost of the project, that is 59 6120, because we are going to add the crashing cost of activity 25 and 35. Here at the last two you see that 1 multiplied by 45 plus 1 multiplied by 50. So that is 59200. Again the crashing cost, the new project cost is increased. Now see, at last stage, crashing the activity 7, 8 and 6, 8 at the same time, because individually we cannot crash activity 7, 8 by 1 week. If we crash activity 7, 8 individually by 1 week, then our critical path will change from 5, 6, 7 in this direction. So that's why we will not crash activity 7, 8 only, because critical path will change. That's why we at the same time we will crash activity 7, 8 and 6, 8 at the same time by 1 week, and the project cost, the new project duration is 25 weeks, and all paths are the critical paths. Here we have calculated the total, that the new project cost is 6110. So here on the critical path, that is in the original critical path, that is 1, 2, 5, 6, 7, 8, all the activities are crashed. Okay, and by crashing all the activities we are getting this much cost, that is 6110. Now the crashing schedule is presented in the above table, that all 6 steps that we have taken, we have crashed, that is presented in the above table, and the project duration, how the project duration gradually reduces, and the total cost of the project, that is indicated in the above table. Okay, so here our answer, if you, our question is the what is the optimal duration of the project and optimal cost, then we will select the answer number 2, row number 2, that our optimal duration is 29 weeks and optimal cost is 5820. If we will reduce duration beyond that, that is below that, we will suffer, we will incur more cost. Okay, the project cost will be increased. Hence our answer for the optimal duration and optimal cost is 29 optimal duration and optimal cost is 5805. But if you want to reduce the project duration, if your primary aim is to reduce the project duration irrelevant of the cost of the project, our answer will be step number 6, that is our minimum duration will be 25 weeks and the associated cost for that is 6110. Okay, so that is depending upon what is the question to be asked, so our answer will be changed. Okay, so I hope you will understand this problem. If any difficulty, any queries, you can call me. Okay, thank you.